So hi everybody, my name's Sophia Zoog, and today I'm going to give you guys a brief understanding of what sleep looks like in the brain, as well as what cognitive neuroscientists currently know about dreams. So of course, sleep is super important to our brain, and there are four different stages. They're called N1, N2, N3, and then REM sleep. REM stands for rapid eye movements because while you're in this stage of sleep and your eyes are closed, they're moving around under your eyelids, which you can see right here. REM sleep is also the deepest stage of sleep, and this full cycle here takes about 1.5 hours total. So let's talk a little bit about what's actually going on in your brain while you sleep. So a PET scan is a piece of technology that's used to take images of brain tissue and other organs in the body. And PET scans have been used on the brain while subjects are sleeping to see the way that cerebral blood flow levels, or CBF, change throughout the sleep cycle. So the patients in one study were sleep deprived before the study for at least 24 hours. And then during sleep, some of the most major increases in CBF happened in the basal ganglia and the thalamus, as well as the limbic and paralimbic areas during REM sleep. So this is the basal ganglia right here, and it's responsible for higher motor control and motor learning. And then this reddish orange thing is the thalamus. The thalamus takes in information from your body and then relays it to all the important parts of the brain. And then this whole kind of section here is the limbic system. And the limbic system is responsible for kind of all of our vital emotions. So during non-REM sleep, the limbic system doesn't experience a lot of CBF. But then when the body enters REM sleep, we see a noticeable spike. So while neurologists aren't sure of the exact reason that it becomes so overtly activated, they suspect that it might have something to do with the richness of the emotions that we experience while we're dreaming, because dreaming happens in REM sleep. And that explanation especially makes sense when we consider that the limbic system wasn't activated during any other phase of REM sleep where dreams aren't occurring. There have also been studies done using other pieces of equipment, such as an fMRI, to evaluate the brain in the deep phases of sleep. So, an fMRI takes a scan of your brain and uses oxygenated blood flow to show neurologists what parts of the brain are activated when a stimulation occurs. So, fMRIs found that during REM sleep, the primary visual cortex, which controls vision, was stimulated, as well as the amygdala, which is responsible for aggression and fear processing, as well as the parahippocampal gyrus, which plays a role in visual processing as well as episodic memory. And all of those findings are interesting because, again, they kind of insinuate that during REM sleep, the brain is still very much alive and processing using episodic memories and the emotional parts of the brain. And then you can kind of see an example of what an fMRI looks like right here. So another part of the sleep cycle is called slow wave sleep, which is different from REM sleep. In slow wave sleep, the brain experiences brain oscillations to kind of keep it in a rested state and to maintain homeostasis. So neurologists also believe that slow wave sleep is important for processing the events of what happened before we fell asleep in the previous wake period. So slow wave sleep includes both slow waves and delta waves, which are very similar, but slow waves generally are related to activity in the brainstem and the cerebellum, near like the back bottom of the brain, while delta waves are related to activity in your frontal lobe. So neurologists also notice that during slow wave sleep, the brain looks very similar to the way it looks while the brain is in a state of resting wakefulness, which is basically just a fancy way of saying like when you're lying down with your eyes closed, but you're still awake. So here you can kind of see how slow these slow wave sleep and like delta waves are compared to when you're like consciously awake and thinking. So now we've talked a lot about what's going on in your brain while you're asleep, and you've hopefully realized that your brain is by no means standing still. So now we have to talk about why it's so important that you're making sure you're sleeping enough every night. First of all, studies done on the amygdala have shown that the amygdala reacts more to fearful face expressions when you're sleep deprived. So the correlation of that is there's a higher indication of depression symptoms shown in people who get poor sleep on a regular basis, which is a symptom that's generally not seen in healthy individuals who sleep enough. The same study also found that people who don't sleep enough generally report higher levels of stress. And that's because the amount you sleep and the quality of your sleep helps soothe your amygdala and regulate stress levels and poor emotions, especially in biological men. There have also been tests performed on rats to see their behavior after being deprived of sleep. So neurologists performed a set of different studies, and in the first, they tested REM deprivation's effects on short-term behaviors in activity levels and honestly didn't notice any significant change. They performed 2 more failed experiments and found that initially the ability to protect themselves from oncoming threats seemingly wasn't affected, like they could still behave somewhat normally. However, then they did a fourth and final experiment where they introduced occasional periodic electrical shocks, which was with the intention that it would show more long-term effects of REM deprivation. So, like if you were deprived of sleep over a longer period of time. And in this case, they found that the rats weren't able to engage in learning behaviors or adapt to new environments nearly as fast as other control rats. And based on the experiments, the neurologists concluded that REM sleep is super important for your brain's ability to stay motivated and to engage in proactive behaviors. The same results have been shown in human brains through the overfitted brain hypothesis, which I'll talk again a little bit about later. The deprivation of REM sleep and not getting enough rest for humans means that your brain doesn't get any time to process the day before, which means that it takes rest and a solid amount of REM sleep for your brain to be able to perform complex cognitive tasks, and that your brain is reliant on sleep to gain learning from cognitive tasks, even if it isn't necessarily like a necessity for simple perceptual tasks. All right, awesome. So I hope that I convinced you to get enough sleep tonight and every night because your brain needs it. Now let's switch gears and talk a little more about dreams. So to be upfront, neurologists don't really know the purpose of dreaming. It's an action that's seen in many species though and has remained active for many years, which indicates that it must have some important purpose in terms of evolution. So some hypotheses say that we dream in order to have an increased ability to generalize, so our brain's able to engage in learning faster. Neurologists also theorize that dreaming must have something to do with emotional regulation, although that's very difficult to prove. I mentioned earlier that dreaming happens while the brain is in REM sleep. And so during REM sleep, your brain is building its ability to perform learning and cognitive tasks and to experience emotion normally. And then during non-REM sleep, while you aren't dreaming, that's when like physical cell repair occurs. So one study was done on 20 college students where they were awoken throughout the night while they slept in a lab, and they were interviewed about what they had been dreaming about. And the study found that throughout the night, the brain experiences dreams of similar themes. And the study also aimed to see how well the subjects were able to remember their dreams and where the source of their dreams came from. And they found that most of our dreams can't be remembered very well, even right after we wake up, especially dreams that happen later on in the night because we kind of lose the details. Of the dreams that the subjects could remember, most of them contained a memory or a source from a recent event, and then a much smaller proportion contained memories or sources from a long time ago. That all supports the hypothesis that the brain dreams as a way to recount the events of the day and to emotionally regulate and generalize what we were feeling. We also can't talk about dreams without also mentioning all of the different things that can go wrong throughout the night while we're dreaming. So one of the most common instances is nightmares. In the midst of REM sleep, the brain is activated in different ways and the body itself has its own reactions. So your heart rate and your breathing tend to fluctuate throughout the sleep cycle. And one study took a look at people who have nightmares frequently and chronically, at least 3 or 4 times every single week. And it ranks those nightmares on a scale of severity ranging from 1 to 4. So 1 is like a mild nightmare, and 4 would be like a severe anxiety attack, screaming and crying, waking up in a state of confusion, or like literally being unresponsive. Neurologists noted that in these really severe nightmares, the heart can even triple its amount of heartbeats per minute, and respiratory rates also increase significantly. So stage 4 nightmares happen when an individual is in a very deep period of sleep, and generally the individual can't recall what the dream was about when they're fully conscious. They also are not normal and are generally associated with a post-traumatic event or a psychological disorder. However, neurologists in the study also concluded that nightmares of all severities occur due to heightened anxiety symptoms in the body, but there's absolutely a range, and your body might not show any symptoms at all after you have a nightmare. Here's an example of when someone had a nightmare and their heart rate like really increased while they were dreaming. Because of this, scientists also theorize that it's possible for REM sleep to be important for regulating anxiety and fear, which could also be somewhat connected to the activation of the amygdala that I mentioned earlier on. Another relatively common sleep condition that varies from the norm is sleep paralysis. So sleep paralysis is a dissociative state where your body is awake, your brain is awake, but your body is still asleep. And so REM sleep has somehow been disrupted along the cycle. So during sleep paralysis, people often mention seeing visions or hallucinations, but not being able to fight them off. And according to studies, almost 30% of people experience sleep paralysis at some point. These studies have also mentioned that while sleep paralysis could happen to anyone, there are certain traits that could put someone more at risk for experiencing it. For example, some mental disorders such as anxiety or PTSD make a person more vulnerable, but you're also more likely to experience sleep paralysis if you actively ingest substances that contain caffeine, alcohol, or nicotine. And being deprived of sleep can also lead to more sleep paralysis dreams. Really anything that brings your body away from a normal nightly sleep cycle. So in conclusion, even though sleep is something that we do all the time, every night, and that is a super important part of our daily lifestyles, we still honestly don't know that much about it. But one somewhat agreed on a hypothesis, which I quickly mentioned earlier, is called the overfitted brain hypothesis. And it essentially states that our body dreams in order to improve task performance through generalization. Our brain experiences so much on a daily basis and so many stimuli that during the night while we dream, it needs to compartmentalize and put things together to be able to maintain a high activity level for the next day. Thank you so much for listening. I hope you really enjoyed my presentation, and here are my references.